Today, on how it's made. Individual transporters. Your own set of wheels. Cedar canoes. This report is sure to rock the boat. And electric guitars. The instrument that revolutionized popular music. A special two-part report that's sure to strike a chord. It's the world's first self-balancing, electrically powered personal transportation device. Built-in sensors and an onboard computer keep this $6,000 vehicle upright as it zooms around up to 3 times faster than walking speed. Perfect for large warehouses, delivery routes, or anyone who just wants a lift. Tough, lightweight construction materials enable the transporter to safely take you almost anywhere you'd otherwise walk or run. This aluminum chassis will house the vehicle's electronics. It can withstand an impact force equivalent to the weight of 3 large cars. Using a press, a worker attaches couplings to 2 motors. These couplings will connect the motors to gearboxes later on. For safety reasons, many of the transporter's components are doubled. Normally, they'll share tasks equally, but any of the twinned parts can do all the work if the other fails. It's what the industry calls redundancy. Using 3 screws on each side, she installs the motors into the chassis. The worker then installs 2 controller boards in the top side of the chassis. Microprocessors in these boards control the motors. Then she adds what's called the balance sensor assembly. This includes 5 gyroscopes and 2 components called fluid tilt sensors. These instruments gauge the vehicle's position relative to the ground. The controller boards check these instruments 100 times per second and adjust the vehicle by rolling the wheels forward or backward when the rider leans either way. Next come wire clusters called harnesses. They connect the vehicle's batteries to the control shaft. The chassis cover doubles as a floor plate for the rider to stand on. When you step on, your weight pushes 4 rubber buttons. These disrupt an optical beam on the controller board, telling the transporter it has a rider. The harnesses fit through holes in the cover, which attaches with 8 screws. Next, she connects the harnesses to a power converter in the base of the control shaft. The power converter uses household electricity to recharge the batteries. Inside the gearbox, 4 gears transfer power from the motor and turn the wheels. The gears' teeth are cut on an angle, so they engage gradually and more smoothly. This keeps the vehicle's noise to a relatively low hum. The worker tightly secures the gearboxes to the chassis with a mallet. Then she opens a waterproof rubber seal and plugs in the machine's power cord. She tests the electrical system to ensure that it's grounded and that there's no short circuit. Next, she uses 5 screws to attach one of 2 plastic fenders. A tapered metal hub connects each wheel to its gearbox. The wheels are about the height of a small bicycle tire, but 3 times wider. A molded rubber and metal mat covers the floor plate and snaps into place on both fenders. After flipping the chassis, a worker connects 2 batteries to the controller boards. When you plug the batteries into a wall socket, they recharge in about 8 hours. The transporter runs as far as 38 kilometers on a single charge, depending on the terrain. This machine tests the rider detect buttons by applying pressure in a random pattern. The rider and cargo must weigh at least 45 kilograms, but no more than 118 kilograms. The machine also tests the wheels and motors. Next, a handlebar on the control shaft. To steer, you turn the hand grip left or right. The motor responds by spinning one wheel faster than the other. You can also spin the wheels in opposite directions to make the vehicle pivot. Ignition keys with computer chips in them restrict traveling speeds to either 9, 16, or 20 kilometers per hour. The keys also instruct the vehicle to make slow, medium, or sharp turns. Now, the fun part, taking each transporter for a test drive. The tester listens for unusual sounds and checks for vibrations coming from the gearboxes. He feels how quickly and reliably the controls respond. He runs the transporter up small inclines. It's designed to conquer slopes of up to 20 degrees, depending on traction with the ground and the weight on board. It goes down over a sidewalk curb just as easily. Only after this thorough test drive is the transporter ready for its first real trip. Canoes are truly vessels of history, dating back as far as 10,000 years. Native North Americans made them with frames of wooden ribs covered with bark. They used these boats to fish, travel, and trade. Today's canoes blend traditional construction with some high-tech materials for even greater durability. Most of this boat's made of white cedar, which is lightweight and weatherproof. But for reinforcement, the rim and leading edges are made of ash, a heavier wood. Construction starts with an upside-down template of the canoe that's 4.8 meters long. A worker clamps 2 long strips of ash, called gun hails, to create the canoe's inner rim, then adds similar strips curving along the 2 extremities. He'll attach the rest of the skeleton to this rim. Workers soften what will be the boat's cedar ribs in nearly boiling water for 45 minutes. The ribs are 5 centimeters wide and almost a centimeter thick. The hot water makes them relatively pliable. Using a hammer for leverage, they simply bend the ribs over the template. Steel guiding strips ensure the ribs are 4.5 centimeters apart. With a pneumatic staple gun, workers fire 2 stainless steel staples through each end of the ribs and into the gun hails. Cement blocks weigh down some of the 43 ribs that workers secure over the entire canoe. At this point, the ribs measure between 1 meter and 1.5 meters long, depending on the area they're covering. The workers will later trim the ends to align them. Next, workers mark the center line along the bottom of the boat with a chalk line. This is where they'll put the first cedar plank to create the skin of the boat. They lay 18 rows of planks on the boat and use a box cutter to shape the ends into a curve. They secure the planks with brass tacks. Brass because it's rust resistant, and its color blends well with the blonde wood. Since the planks are straight angled, this process leaves some wedge-like spaces they'll cover separately. They cut thin wedges of wood to cover the remaining spaces. It takes 8 hours and 2,500 tacks to fit all the planks on the boat. In total, it takes one person 30 hours to make one canoe. Using a circular saw, a worker trims the excess from the ends of the ribs. Then, 2 workers lift the boat off the template, flip it right side up, and set it down to rest on 2 sawhorses. Here, a worker feels inside the boat for any protruding tacks. He uses a hammer and metal block to flatten them. Most were deflected earlier when they hit the metal guide strips on the template. A worker tightens a nylon string between the gun hails, bringing the boat's extremities together in points. He joins the tips of the gun hails with a screw at both ends of the boat. Then he installs triangular pieces of mahogany. This hardwood stands out visually when stained and also reinforces the ends of the boat. Workers then trim and close off the ends. Next, they attach 2 more gun hails with 44 screws to create the outer rim of the boat. To protect the wood and make its surface watertight, workers cover the bottom of the canoe with fiberglass cloth. Then they seal it with 3 coats of clear epoxy resin, which will need up to 2 hours of drying time between coats. Workers reinforce the front and back of the boat with more fiberglass and more resin. They do this because these areas will hit rocks and the shore more often than other parts. A worker fills holes he drilled through the bottom of the boat with silicone. This helps attach the keel, the spine of the boat, as well as 2 long brass components on top of the keel. Workers complete this step by flipping the canoe and attaching 37 screws through the silicone and into the keel. After thawing frozen strips of rawhide leather in water, a worker cuts holes in them. These holes enable her to weave the strips together to cover the canoe's 2 ashwood seats. It takes her about an hour to weave the required 20 meters of rawhide. The pattern is similar to what you see on traditional snowshoes. It takes 2 days for the leather strips to dry out and tighten. Workers then protect and strengthen them with marine varnish. Then they install the seats inside the boat with 4 brass bolts. Next comes the yoke, a bar running across the width of the boat. It's designed to fit on your shoulders when you carry the boat upside down. The other bar is for securing gear safely while you're out paddling on the water. Bon voyage! The electric guitar dates back to the 1920s. The original idea was to amplify the sound of the acoustic guitar. The first commercially successful model came out in 1932. By the 1950s, the instrument underwent a radical change, its body evolving from the traditional hollow shape to a thin, solid block of wood. Guitar bodies are usually made of mahogany, poplar, or certain maple species, lightweight woods that are flexible enough to produce the right balance of treble, mid-range, and bass vibrations. Workers first saw a plank of wood into specific widths. They plane the pieces to a specific thickness, usually in the range of 5 to 10 centimeters. Then they mark them with the same number so they'll end up in the same guitar. Mixing pieces from different planks would combine different wood densities and make the body vibrate unevenly. Damp wood tends to warp, so the pieces have to go into a heated room until their moisture content drops to less than 6%. This takes about 2 months. Once the wood dries out, workers glue and clamp the pieces together, setting them in a vise for 3 hours until the glue dries. The water-based glue re-wets part of the wood, so the block has to go back into the drying room for another 2 months. When it comes out, it goes onto a holding device. Then, a computer-guided cutting machine uses 8 different heads, one after another, to gradually carve the body shape. This is a semi-acoustic model, so the body has some hollowed-out areas. After a fine sanding to smooth the surface, they trim the contour at a 45-degree angle using a small stainless steel blade. Then they sand again. By this point, they've also inserted round metal fixtures to hold the bolts that'll attach body and neck. To construct the neck, they slice a piece of mahogany or hard rock maple in 2 using a diamond-edged saw for a perfect cut. Then they glue a 1.27 millimeter thick sheet of maple veneer onto one piece. This will be the front surface of the neck. Now they flip the piece over and glue it to the other one. Flipping inverts the wood grain. This strengthens the neck, enabling it to withstand the tension of the guitar strings. The maple veneer hides and reinforces the joint. They clamp the components in a vise for 3 hours until the glue sets. A computer-guided cutting machine contours the neck shape and cuts a groove down the middle for a steel bar called the truss rod. When the neck bows from tension created by heavy gauge strings, you straighten it by adjusting the protruding end of the truss rod. Next, the fingerboard, the surface against which you press the strings to produce different notes and chords. It's made of maple, ebony, or rosewood. After gluing the fingerboard over the truss rod, they place the neck into a vacuum press. The press sucks out all the air, compressing the components into one solid unit. Once the glue dries, the neck goes onto a computer-guided carving machine. Its 12 different cutting heads finalize the shape. Next, a 22-blade saw simultaneously cuts very precise slots for 22 fret wires, the metal lines on the fingerboard. A worker rounds off and smooths the back of the neck against a belt sander. Then installs the fret wires. The wires are made of nickel and lead. They have teeth on the bottom that grab the wood. That's why it's essential that the slots be a very precise width and depth. Finally, they run the sides of the neck against a sanding belt. This trims off the excess fret wire and rounds off the edges of the fingerboard. Back to the body now. A worker puts it in a silkscreen printer to apply the company name. The ink dries in just seconds under ultraviolet light. After applying a sealant to block the wood's pores, they spray on up to 22 coats of wood stain and lacquer. This protects the wood and gives it a sexy semi or high gloss finish. Now on to the mechanics. An electric guitar works like this. A magnet and coil assembly called a pickup works like a mini microphone. It picks up the sound vibrations of the strings and sends them to an amplifier, which sends them to a speaker, which emits that trademark electric guitar sound. Before installing the electronic components, though, a few final steps. After a 6-week curing period, they wet sand the painted and lacquered wood. Then buff until the surface is so glossy, it produces a mirror finish. Then they polish it with wax. If the frets aren't level, the guitar will buzz. So workers color the top of each fret with a marker, then run a sheet of fine sandpaper down the fingerboard. The ink rubs off any frets that are higher than the rest and have to be filed down. But filing flattens the frets' edges, so workers round them off using a special curved file. Then, with very fine sandpaper, they buff away the filing marks. They clean the fingerboard with mineral oil. This also nourishes the rosewood so that it won't dry out and crack. Now they turn an Allen key in the truss rod to straighten out the neck. This gauge measures the curve. When the needle hits 0, the neck is perfectly straight. Now the 6 tuning keys, one for each string. Depending on the model, these steel keys are plated with either gold or nickel or painted black. You turn the black acrylic peg to tighten or loosen the string for tuning. Workers use a digital gauge to measure the height of the nut, a thin piece of either bone or very hard plastic with 6 slots to space the strings. If it isn't in precisely the right position, tuning will be off and the strings will buzz. Now the neck is ready to join the body, courtesy of 4 bolts driven from the back of the instrument. They fit into those round metal fixtures we saw in the previous segment. And now, the electronic components. Workers begin by soldering control knobs for the volume and tone to the pickup selector switch, the switch that activates any of the pickups, sets of magnets with wire coiled around them. Like miniature microphones, they pick up the sound vibrations entering their magnetic field, transform them into electronic signals, which then go out to the amplifier and speaker. One pickup will be just above the bridge, a brass piece that anchors the other end of the strings. The pickup has 1 magnet and wire coil for each string. Standard electric guitars don't have a pickup at the bridge, but this model has one to enable the instrument to also sound like an acoustic guitar. You can even use the electric and acoustic sounds together. Workers drill holes in the body for installing the bridge, using a template as a guide. They attach the bridge with screws. Then install the bridge pickup just above it and the body and neck pickups above that. Then they flip her over and hook up what's called the tremolo, a lever-activated set of steel springs that temporarily loosen the guitar strings. The musician uses the tremolo on select notes and chords to create a quivering effect, that distinctive electric guitar sound. The volume and tone knobs come next, tucked into a cavity in the back, then secured to the front with a nut. Now, the pickup selector switch. It also comes through the back to the front of the instrument. Then they add the last electronic component, a jack for the cable going to the amplifier. They plug in the cable and, flicking the selector switch, do a tap test on each pickup. Now it's time to string the guitar. They pull the steel strings from the back through the bridge in the front. Then wind them onto the tuning keys, using a drill with a special adapter. Then it's into a soundproof booth to tune the guitar with the help of a digital tuner. And then take it for a test drive.